In this episode, we're going to focus on cloud storage security because a large portion of high-impact cloud incidents are really data exposure incidents. When people hear cloud storage, they often think of it as a simple place to put files, but in practice, cloud storage services are foundational building blocks used by applications, analytics, backups, and collaboration workflows. That means cloud storage can contain the most valuable data in an organization, sometimes mixed with convenience data that still becomes sensitive when combined with other information. The reason cloud storage is tricky is that access is controlled through a combination of identity permissions, storage policies, network reachability, and configuration defaults, and a single mistake can turn a private dataset into a publicly accessible one. Beginners also tend to assume encryption solves everything, but encryption is only one part of confidentiality, and it does not automatically prevent data leaks if access controls are weak. The goal of securing cloud storage is to keep data private, keep it intact, and keep it available to the right systems and people, while maintaining visibility into what is being accessed and by whom. By the end of this, you should be able to explain what buckets and shares represent as concepts, why encryption defaults matter, and how common misconfigurations lead to real-world data leaks. A helpful starting point is understanding that cloud storage comes in multiple forms, and security depends on which form you are using. Object storage is often used for large collections of files and data objects, and it typically organizes data in containers sometimes described as buckets. File storage is often used for shared file systems, and it can feel like a shared drive or network share that multiple systems can access. Block storage is often used for attaching storage volumes to computing resources, behaving more like a disk. Each type has different access patterns and different risks, but beginners can benefit from one common idea. Cloud storage is managed by policies, not by physical locks. You do not walk up to a storage array and plug something in. You define who can read, write, list, or delete data, and those decisions are enforced by service-level controls. This makes cloud storage flexible, but it also makes security dependent on configuration correctness. If you define access too broadly, the service will faithfully allow access too broadly, and that is how leaks happen. Understanding the type of storage you are using helps you reason about how access is granted and how exposure might occur. Buckets, as a concept, are containers for objects, and they come with a common beginner misunderstanding. People assume that because a bucket belongs to their organization's cloud account, it must be private by default. Privacy depends on policy. A bucket can be configured to allow public access, to allow access from specific identities, or to allow access from certain conditions, and small configuration differences can have huge consequences. Another important concept is that buckets often support listing and reading as separate actions, meaning someone might be able to read an object if they know its exact name, even if they cannot list the entire bucket. That nuance matters because it affects how exposure is discovered and exploited. Buckets are also used by applications, which means access can be granted to service identities that operate continuously, and those permissions can become powerful. For beginners, the key idea is that a bucket is not just storage. It is an access-controlled service endpoint. If you treat it like a passive folder and ignore the policy layer, you will miss the security decision that actually determines confidentiality. Shares, as a concept, represent storage that is meant to be accessed by multiple users or systems, often through familiar file access patterns. The risk with shares is that familiarity can cause people to apply old habits, such as granting broad access because it is easier than managing permissions precisely. In cloud environments, shares can be attached to multiple systems, and if access controls are not carefully designed, a compromise of one system can become a path to accessing shared data. Shares can also become places where sensitive data accumulates over time because they are convenient dumping grounds. Another risk is that access models for shares may combine identity permissions with network reachability, meaning that if a share becomes reachable from a wider network segment than intended, access can expand unexpectedly. For beginners, the important point is that shared storage is a risk amplifier because it aggregates data and because it serves multiple workflows. If you do not enforce least privilege and segmentation around shared storage, you create a high-value target that can expose large amounts of information in one incident. Securing shares requires careful access boundaries and ongoing hygiene, not just initial setup. Encryption is one of the most discussed cloud storage topics, and it is also one of the most misunderstood. Encryption at rest means data is stored in an encrypted form on the provider's underlying media, and encryption in transit means data is protected when moving over networks. Both are important, but encryption does not automatically prevent leaks if unauthorized identities can access the data through legitimate interfaces. If an attacker steals credentials and uses them to read data, encryption at rest does not stop them, because the storage service will decrypt data for authorized access. This is why encryption must be paired with strong identity controls, strong permission design, and monitoring. Encryption defaults matter because they influence whether data is protected when teams move quickly and forget to set extra options. In some environments, encryption at rest is enabled by default, which is helpful, but you should still understand what that default means and whether it matches your requirements. For beginners, the takeaway is that encryption is a necessary layer, but it is not the main gatekeeper. Identity and policy are the gatekeeper, and encryption supports confidentiality against certain threats, such as physical media exposure, but not against policy mistakes. Data leaks in cloud storage most commonly happen through misconfiguration, and misconfiguration often looks like overly broad access combined with poor visibility. One pattern is public access that was enabled intentionally for a short-term need, such as sharing files externally, and then left enabled for longer than intended. Another pattern is accidentally granting broad access through permissions that were meant for a specific application but were applied to many identities. Another pattern is relying on inherited permissions, where a role or group has broader rights than the team realizes and access expands quietly. Yet another pattern is exposing data through backup artifacts, snapshots, or copied datasets that were created for analysis and then forgotten. The common thread is that cloud storage makes copying and sharing easy, which is operationally valuable but also risky. For beginners, it helps to think of cloud storage leaks as policy leaks more than technology leaks. The storage service is doing what the policy told it to do, and the leak exists because the policy allowed the wrong access. This is why careful permission design and ongoing review matter more than flashy tools. Another common misconfiguration trap involves misunderstanding the difference between access to the storage service and access to the data itself. You might restrict who can manage a storage resource, but still accidentally allow broad read access to the data. Conversely, you might restrict data access but leave management access too open, allowing someone to change policies and create new access paths. This is where separating duties and limiting administrative access becomes important, because the ability to modify storage policies is itself a high-risk capability. For beginners, the key idea is that control plane permissions, meaning the permissions to change configuration, can be as dangerous as data plane permissions, meaning the permissions to read and write data. If an attacker can change storage policies, they can often create a leak even if the data was protected moments before. That is why identity security and role design are so central to storage security. Cloud storage is not just about protecting data. It is about protecting the ability to decide who can access that data. Visibility is the other half of preventing storage leaks, because you need to know what is being accessed and whether access patterns look normal. Useful visibility includes logs of who accessed data, what actions they performed, and from where, as well as logs of policy changes that might alter access. Monitoring helps you detect suspicious patterns, such as large downloads, unusual access from unusual identities, or access at unusual times. Visibility also helps you audit and validate that access controls match intent, because you can confirm that only expected identities are touching sensitive datasets. For beginners, the key lesson is that storage security is not complete without monitoring, because even well-designed access controls can be bypassed by stolen credentials. If you can detect unusual access quickly, you can contain the incident and reduce harm. Monitoring also supports lessons learned, because if a leak occurs, logs help you determine scope and root cause. This ties back to earlier discussions about logging and SIEM analysis, because storage logs are high-value signals for data-centric threats. Another important concept is data classification and lifecycle management, because not all data needs the same level of protection, and not all data should be kept forever. In practice, cloud storage often becomes messy because teams store data without labeling it. then forget what is sensitive and what is not. Classification is the practice of identifying data sensitivity, such as whether it contains personal information, secrets, or proprietary material, and then applying appropriate controls. Lifecycle management includes deciding how long data should be retained, when it should be archived, and when it should be deleted. For beginners, the key is to see that the longer sensitive data sits around, the more likely it is to be exposed eventually, especially as permissions drift over time. Reducing unnecessary data retention reduces risk, and it also reduces the blast radius if an incident occurs. This is not about deleting everything. It is about aligning retention with purpose. When data is managed intentionally, access controls are easier to design and monitoring is easier to interpret because you know what is supposed to be where. When you bring these ideas together, securing cloud storage means treating storage as a policy-driven service that can leak data when access is too broad, defaults are misunderstood, and visibility is weak. Buckets and shares represent different storage access patterns, but both are controlled by identity and policy, and both can become high-value targets when sensitive data accumulates. Encryption defaults matter because they influence baseline confidentiality, but encryption does not compensate for poor access controls because authorized interfaces will still deliver data to whoever the policy authorizes. Common leak patterns involve accidental public exposure, overly broad permissions, inherited access, and forgotten copies and backups, all of which are amplified by the cloud's speed and convenience. Visibility through logging and monitoring is essential because it provides evidence of access and changes, enabling faster detection and more confident response. For beginners, the most important takeaway is that cloud storage security is not a one-time configuration choice. It is an ongoing discipline of least privilege access, careful policy management, continuous review for drift, and high-signal monitoring of sensitive data access. If you can explain these concepts clearly and keep your attention on policy, identity, and visibility, you will avoid many of the most common and damaging cloud storage mistakes.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.